Hey everyone, what I'm showing you here is an ACT test example. This is a passage from the ACT test. Now, you may have taken the pre-ACT test recently, and the pre-ACT test had questions like this as well. This is the science portion. Why I'm showing you this is that one thing that is important in science is to be able to get information and analyze that information. So the ACT test gives you passages. These are reading passages, usually accompanied by a data table or a graph or both. And it's your job to get information from those passages. So if we take a look at this first one, it's talking about spent fuel, a radioactive waste, is often buried underground in canisters for disposal. As it decays, SF, spent fuel, generates high heat and raises the temperature of the surrounding rock, which may expand and crack, allowing radioactivity to escape into the environment. Scientists wanted to determine which of four rock types, rock salt, granite, basalt, or shale, would be least affected by the heat from SF. Remember what that means? Spent fuel. The thermal conductivity. What does that mean? How well heat is conducted through a material, and heating trends of four rock types were studied. Then it talks about each study. Study 1, 50 holes, each zero point 0.5 meters across and 20 meters deep, were dug into each of the following: a rock salt deposit, granite bedrock, basalt bedrock, and shale bedrock. A stainless steel canister containing zero point 0.4 metric tons of spent fuel was buried in each hole. The rock temperature was measured next to each canister after 1 year had passed. The results are shown in Table 1, along with the typical thermal conductivity of each rock type in watts per meter per degree Celsius at 25 degrees Celsius. The higher the thermal conductivity, the more quickly the heat is conducted through the rock and away from the canisters. So then it shows a table with the type of rock. Here's rock salt, granite, basalt, and shale, and then the temperature of each. And then here's a graph. This graph shows the thermal conductivity of the four rock types. So there's a key to the graph, there's a title. It's actually shown right here. The title would be something like it's the scientists determined the thermal conductivity of four rock types. That's what you're looking at, the thermal conductivity, something you don't need to know about right now. But you can see the dotted line and then the dots with the dashes and the solid line and then the smaller dash line. And each of those represent a different rock type. And then it says in study 3, scientists calculated the temperature increase that would be expected over 100,000 years. And you can see the different rocks. The basalt is the solid line. The next one is the shale. The next one is granite. And the bottom one is rock salt. Okay. So, of all that information, then there's questions to answer. According to study 2, the thermal conductivity of rock salt measured at a temperature of 500 degrees Celsius would be closest to which of the following values? So we have to look at study 2, we have to look at rock salt, we have to look at 500 degrees Celsius. So we're going to look at study 2. Here it is, study 2, rock salt. Rock salt, I'll zoom in, is the regular just a dashed line, so it's this one. Okay. And then 500 degrees Celsius, is that what we're looking for? Let me look back. According to study 2, the thermal conductivity of rock salt measured at a temperature of 500 degrees Celsius would be closest to what? Going back to the graph. Now you'll see the temperature goes 0, 100, 200, 300, 400. So you have to, it's called extrapolate, right? You have to bring the data further out. So you have to look at what's happening to the data. Well, it started off here at about 6, 5, 4, 3, and does it ever really get to 2? It's kind of leveling off, isn't it? So you're going to extrapolate where might that line be for the 500 degrees. So it's going to be closest to 1, 2, or 3. Let's take a look at our answer choices. 1, 2, 3.5, or 4. What would be the best answer? So the next question says, according to study 3, if another set of temperatures had been calculated for a time 1 million years in the future, the calculated temperature increase in any of the four rock types would be most likely be closest to what? So let's take a look. We need to find study 3, 1 million years into the future, and the calculated temperature increase in any of the four rock types. So down here is study 3. This goes the time. There's 1 year, 10 years, 100 years. These go up by a factor of 10 each time, right? 100 to 1,000 years. There's 10,000 years, 100,000 years. So the next step is going to be 1 million years. So you can extrapolate these lines. Where would they be at 1 million years? Well, I think they're going to be down here, close to 0, right? So what are your answer choices? 0, 10, 20, or 30. Looking back at the graph, well, it's certainly not, doesn't appear it's going to go back up to 10, 20, or 30. So hopefully the best answer choice is what? So I'm going to stop here. I just wanted to give you a sample. What you should have gotten for the first one, I believe, was closest to 2, and the second one was 0. Okay. So why are we learning this? As you can see, the ACT test relies heavily on your ability to find information and to figure out what graphs tell you. Okay, so today we're going to take a look at an interesting thing called Turner's Graph of the Week. So, Turner's Graph of the Week is an excellent website. They have fun graphs that have lessons to them that are kind of topical, and they let you kind of understand things. So, in order for us to start that, we're going to do this lesson. This is an introductory lesson to learning how to understand and analyze real world data. Okay. If I go to the first one, let's take a look at this. Okay, you can see this is a bar graph, right? And you can see at the bottom, this is going to be, was going to be a pair deck if we did this live, that we can just kind of add information. But I'm going to have you do it as part of this Ed puzzle today. It says, describe in your own words what you think is happening in the graph below. So take a look. What do you think is happening in this graph? Well, we can see some numbers, right? We see some data. We see some blue data, 85% and 32%. And these are together, 72 and 15%. So go ahead and make a guess. What's your best guess as to what's happening in this graph? What does this graph represent? Next, what information do you think we need to understand this graph better? What's something we need that would help us to understand this graph better? Does this help? What could the x-axis represent and what could the y-axis represent? So before we get to those questions, the blue one, percent who report using the platform. The green bar represents percent who say the platform is their most used. So what do you think the y-axis represents here? And what do you think the x-axis represents? Now, will this help? What if I add a picture? What might this graph represent? Do we have enough information now to figure out what this graph is about? As you can see now, we've added some things to the graph. Some things that are quite important to a graph, right? We have a quantity along the x-axis. So along the x-axis, you can see we have YouTube, Instagram, Snapchat, Facebook, Twitter, Tumblr, Reddit, and none of the above. What do the numbers along the y-axis mean, do you think? Well, that represents the percent, right? And if we look at the blue, percent of people who report using that platform. So 85% of the people polled reported using YouTube. We we also need a title or heading for the graph. And so that some of you might be looking at these thinking, well, that's kind of some of these aren't really used anymore. If you look way down at the bottom, you see this was from March 7th to April 10th of 2018. So we need a heading. It's top social media platforms among US teens aged 13 to 17. But this is from a few years ago, right? 2018. So knowing this, what do you think the top social media platform might be in 2025? Do you think there will be an upward or downward trend in the use of social media and why? And since we're doing this as a ed puzzle, I'm not going to have you discuss in your groups, but certainly feel free to talk to your friends about what you think. Has the popular social media for the year 2025 been invented yet? Um, is the one that if you use social media, is the one that you tend to use the most? Was that invented 5 years ago? Let's try another graph. Check out this one. It says waiting longer to tie the knot. Americans are waiting longer to get married than they did decades ago, with larger percentages of both men and women in their 20s and 30s who have yet to say, I do. So we have age from about 20 to 28 years old, right? That's the span they're looking at. Here's 1950, 1960, 1970, 1980, 1990, 2000. I wonder when, you know, I wonder when your parents, if they were married, what year that would have been, and if that's kind of how old they were. You can take a look at that. Estimated median age. Median's kind of like average, right? It's the middle. Median is the middle, meaning there's just as many people older as younger than that were getting married. Percentage of men and women never married by age. So here's the age 20 to 24, 54%, 54.7%. Now remember, women are red. So 36%, roughly 35.8% in 1970, women were never married in that age, and about 54.7% of men. Whereas in 2003, look how the percentages jumped to 2003. So after you've taken a look at this, what is the topic of this graph? What do the X and Y axis represent? What observations can you make about the graph? What do you predict will be the average age of marriage in 10 years? So now, what I'd like to do is write a summary of what that graph was telling you. And we'll do that as a question on the Ed puzzle. I'll go back to the graph so you can look. Here's your assignment, and you're going to find this assignment in Schoology as a Schoology assignment. I'm going to change it just a little bit possibly from here. Let's take a look. Your homework assignment on Schoology. Think of something that interests you. Might be music, movies, baseball, skateboarding, gaming, law enforcement, cats, art, reading, soccer, anything that interests you. Do a Google search and find a graph that represents your interest. It can be a line graph, it can be a pie chart, it can be a bar graph. It doesn't matter. Be sure to choose a graph that's detailed and easy to understand. Insert the graph into your Schoology assignment. Don't write anything about it just yet. Just insert the graph and turn in your Schoology assignment. Okay, so that's your homework. Find a graph of something that interests you. As we're finishing up, what do you think about this graph? What does this show? The title is Words per Song by Genre. Genre is like rap music, rock, and country. So only those three. What does the x-axis represent? That's this axis. What does the y-axis represent? According to this graph, what type of music has the most words per song on average? Let's take a look at this graph. What's the title? What does the x-axis show? Number of legs, 0 to 8. And let's just take a look. 0 legs, 1 leg, 2 legs, 3 legs, 4 legs, 5 legs, 6 legs, 7 legs, 8 legs. Okay, you've got your homework. Go ahead and turn in your Edpuzzle. And good luck. Let me know if you have any questions about the ACT science test. Now, you have probably taken the pre-ACT, and so you know a little bit about what is expected. So let's talk about it. The ACT science test relies heavily on your ability to read passages and interpret graphs and data and answer questions based on those. So let's take a look at an example. It says directions. The passage in this test is followed by several questions. After reading the passage, choose the best answer to each question and fill in the corresponding oval on your answer document. You may refer to the passage as often as necessary. You're not permitted to use a calculator. So look at passage 4. I'm going to briefly go through the passage with you. If you can enlarge this on your screen to read along, that'd be a good idea. It says spent fuel, abbreviated SF, a radioactive waste, is often buried underground in canisters for disposal. As it decays, spent fuel generates high heat and raises the temperature of the surrounding rock, which may expand and crack, allowing radioactivity to escape into the environment. Scientists wanted to determine which of four rock types, rock salt, granite, basalt, or shale, would be least affected by the heat from spent fuel. The thermal conductivity, how well heat is conducted through a material, and heating trends of the four rock types were studied. Okay, so I'm going to stop there for a second. Understand you don't need to know all of the science behind this. It's giving you the information in the reading that you need to know. There's some vocabulary and certainly a level of reading that you'll need to be able to do. But understand you're not expected to know radioactivity and things like that. Study 1. It says 50 holes, each zero 0.5 meters across and 20 meters deep, were dug into each of the following. a rock salt deposit, granite bedrock, basalt bedrock, and shale bedrock. A stainless steel canister containing zero point 0.4 metric tons of spent fuel was buried in each hole. The rock temperature was measured next to each canister after 1 year had passed. The results are shown in Table 1, along with the typical thermal conductivity of each rock in watts per meter per degree Celsius at 25 degrees Celsius. The higher the thermal conductivity, the more quickly heat is conducted through the rock and away from the canisters. So let's take a look at that. Table 1, thermal conductivity, and there's that unit they were talking about. Don't worry about the unit just yet. And rock temperature in degrees Celsius. So we have the rock salt is the first one, 5.70 and 110 degrees Celsius. Salt, 2.8, 121 degrees Celsius. Granite, 1.26, it was 165 degrees Celsius. And basalt, 1.57, 146 degrees Celsius. So that's what that table shows. Okay, we might need to come back to that later. Study 2. So scientists determined the thermal conductivity of the four rock types at a number of different temperatures between 0 and 400 degrees Celsius, and the results are shown in Figure 1. So here's a graph, right? That's what we're focusing on right now. We're going to learn about how to interpret graphs. This graph, and I'm going to go ahead and zoom in so you can see a little bit better. There's a key to the graph, okay? It's showing thermal conductivity on the y-axis, 0 to 7, and temperature in degrees Celsius. So you can imagine 0 degrees Celsius, that's freezing point of water, 100 degrees is boiling point of water, 200 degrees, 300 degrees, 400 degrees. So as you're heating up the temperature, right, the thermal conductivity and what occurs with that. And then in the key, it shows you the different rock types: rock salt, granite, basalt, and shale. Okay, let's look at study 3. I'm going to keep it zoomed in. The scientists calculated the temperature increase that would be expected over a period of 100,000 years in each rock type at a point within a site holding buried spent fuel. The results are shown in Figure 2. So let's take a look at this graph. When you look at a graph, take a look at the axes. The x-axis here is in years: 1 year, 10 years, 100 years, 1,000 years, 10,000 years, 100,000 years. Notice how it goes up by a factor of 10 each time. The the y-axis is labeled rock temperature increase in degrees Celsius. So this is, to interpret this graph, they're saying how hot should the rock get over the next several years because of the spent fuel, the radiation. Okay, it starts off here, and it looks like it peaks, and all of them, one of them goes really high to 70 degrees Celsius. That's the, if we look up our key, basalt. The next one is shale. The next one is granite, and the bottom one is rock salt. Okay, I'll zoom back out. Let's leave it at those two graphs for now. I'm going to go up to the questions. We're going to do two of the questions here. Number 1, I'll zoom in. You can see I've already selected one. Maybe that's the correct answer. According to study 2, the thermal conductivity of rock salt measured at a temperature of 500 degrees Celsius would be closest to which of the following values? Okay, so let's take that apart. We have to look at study 2. We have to look at rock salt, 500 degrees Celsius. So I'm going to go back to study 2. Here's study 2. Okay. The rock salt is the dashed line, and 500 degrees Celsius. What is the thermal conductivity? Well, here's rock salt. At 100 degrees Celsius, 200, 300, 400. Oh, 500 isn't on the scale. We have to do what's called extrapolate. To extrapolate means to go beyond the data to predict what the number might be. Okay? Well, what do you think it would be? Here's the curve. It seems to go down fairly quickly and then it kind of levels off and then it's kind of going almost parallel. If we follow these lines over, it's going pretty much parallel to 2. All right. It's not going below 2 and it doesn't look like it's going to go back up. Right. So let's take a look at our answer choices. According to study 2, the thermal conductivity of rock salt measured at a temperature of 500 degrees Celsius would be closest to which of the following values? And I chose 2. Do you think that's the best answer? Let's try the next one. Okay, it says, according to study 3, in another set of temperatures, if another set of temperatures had been calculated for a time a million years in the future, the calculated temperature increase in any of the 4 rock types would be most closely associated, most would likely be closest to what temperature? All right. So we have to go to study 3 and look at a million years in the future. Here's study 3. Okay. And now here's the graph. All of them go up and they come down. Remember, we go up by a factor of 10. There's 10 years in the future, 100 years in the future, 1,000 years in the future, 10,000 years, 100,000 years in the future. Where do you think it would be at a million years in the future? What temperature do you think would be closest to? And you can see my answer as being 0. Do you agree with that? Okay, we're going to stop there. We're going to go to the next part of our activity, which is a slideshow. This is called Graph of the Week, and it corresponds to some really good graphs to help you understand how to get information from graphs. Graphs are everywhere, right? You can see them on websites. They're shared on social media sometimes. They're on the news a lot. They're in newspapers, if you know what those are, and magazines. So let's take a look at graphs. Check out this one. So go ahead and answer this question. I'm going to put it up on the Edpuzzle. In your own words, what do you think is happening in this graph? What information do you think we need to understand this graph better? Well, let's take a look. Does this help? So what have we added? Let's take a look at the graph. We have a bar here that says 85% and a bar here that says 32%. Those seem to be together for some reason, 72% and 15%. Well, now we put a key on there. Percent who report using the platform. The green is the percent who say the platform is their most used. Okay. So what could the x-axis represent? Right? That's what could these bars mean, each of these segments? And what could the y-axis represent? Will this help? We add a picture. Now, what do you think this graph is talking about? Now, do we have enough information to figure out what this graph is about? Let's take a close look. Now, you might look at this and you're saying, oh, here's, top social media platforms among US teens, 13 to 17. And you might look at these and possibly you don't see ones that you are familiar with or that you like to use. I think most of them you do know. This is actually from, if you look way down here, if you can see it, this is from the spring of 2018. So 2.5 years ago. Well, if we take a look at this, we have now added a quantity along the x-axis. What have we added? The different types of social media that were used in 2018. And we have also indicated what the numbers on the y-axis mean. These are the percent of users, right? The people using it. And we need a title top social media platforms among US teens aged 13 to 17. So here's a question for you. This is 2.5 years ago. In 4 years, what do you think the top social media platform might be? Is the social media platform, if you use social media, that you prefer, was that around 4 years ago? It's a good question. So, do you think there will be an upward or downward trend in the use of social media? Why? Now, it says to discuss in your group. Since we're on Edpuzzle, I'm not going to have you discuss formally in your groups. If you'd like to talk about this graph with your table partners, you certainly could. Um, I'd like to know your opinions of what the social media was 2.5 years ago compared to what you're using now. Let's try another graph. Okay, take a look at this one. So, first question, what's the topic of the graph? What does the x-axis represent? What does the y-axis represent? What is one observation you can make about this graph? And make a prediction. What do you predict will be the average age of marriage in 10 years' time? So, in the year 2031, what do you think the average age of marriage would be? So, just to review this graph, waiting longer to tie the knot, Americans are waiting longer to get married than they did decades ago, with larger percentages of both men and women in their 20s and 30s who have yet to say, I do. And you can see it started here in 1950, where the average age of a woman looked to be 20, then it went to 21, 22, 23, 24. And at the time of this, which looks to be maybe 2004 or so, 2003 possibly, 25 years old. Average age of a man at the time was 23, kind of hovered there until the mid 1970s when it spiked up. And currently, well, not currently, in 2003 is 27. I wonder what it is today. We're not going to do that activity. I'm going to give you a homework assignment. Find a graph. Okay. You'll find this on Schoology. Think of something that interests you. Could be music, movies, baseball, skateboarding, gaming, law enforcement, cats, art, reading, soccer, whatever is of interest to you. What do you like? Do a Google search. Just type in graph of fill in the blank and find a graph that represents your interest. It can be a line graph, it can be a pie chart, a bar graph, it doesn't matter. Be sure to choose a graph that's detailed and easy to understand and read. Insert the graph into your Schoology assignment. You don't have to write anything about it just yet. Okay, just insert a graph that interests you and turn it in. Let's take a look at a couple more graphs. What do you think of this one? So, when you first look at a graph, what do I want you to do? Read the title. Words per song by genre. If you don't know what genre is, right, that's just a type of music. And they're looking at three genres of music: rap, rock, and country. And I can see those in the key right here. Rap is the salmon color, rock is the green, and country is the blue. And then they have on the x-axis word count, 0 words all the way up to 1,000 and more words. The number of songs. Okay. You can see that there are about 600 or so songs they looked at in rap music, maybe 900 and some in country, and 1,300 or so in rock. So, what is the point of this graph? If I were to ask you, according to this graph, what genre of music has the most words per song on average? What would you say? How about this graph? Read the title. Cuteness versus number of legs. Now, this is kind of an opinion, kind of a fun graph, isn't it? It's probably not based on any data, but it's an interesting graph because they have number of legs 0 to 8, and they have ranked cuteness from kill it, creepy, unfortunate, pretty normal, cute, adorable. So with 0 legs, they say that's creepy. 1 leg, unfortunate. 2 legs, pretty normal. 3 legs, it drops back down to unfortunate. 4 legs, adorable. 5 legs, it drops down to somewhere between creepy and unfortunate. 6 legs, somewhere between kill it, and creepy. 7 legs, closer to kill it, and of course 8 legs, kill it, kill it. You've got your assignment. Go find a graph and share it with me on Schoology. Good luck. Let me know if you have any questions.